so going on page 52. All right, so before we actually get into what the remainder theorem is, we've got a little warm-up here that we're just going to do together. It says, consider the polynomial function. It's right here. And it says, divide the function by x plus 4. All right, so that's something that we're completely capable of doing, yes? Would you choose long division or synthetic division? Yes, me too, synthetic. Okay, so what number goes on the outside? -4. Okay, good. So then in here in the top, I'm going to get 1, 1, -4, and 41. And the most common mistake on synthetic division, especially on your test, was not writing the numbers down correctly to begin with, so just be careful with that. So I bring the 1 down. -4 times 1 is -4. Get -3. -4 times -3 is a positive 12. So this gives me positive 8. What's -4 times 8? Times. -4 times 8. Negative 32. And remember, if you don't know those, which we should, but multiplying anything by 4, you just double it and double it again. So 8 times 2 is 16. 16 times 2 is 32. You can do it that way too. And so then this gives you what? What goes right here? 9. Okay. So then after I divide, my answer is, this was x cubed, so this is x squared minus 3x plus 8 plus 9 over x plus 4. Okay, we all agree with that? And we are going to start using synthetic division for things other than just getting an answer like that we don't even know why we care about an answer like that. We're getting there too, okay? All right, so then we're going to find f of -4. So if I take -4 and I'm going to substitute it in here. Now, one of the things that most of y'all are doing okay with, but not everybody, is I don't just start by writing stuff down. You've got to label what this stuff is. So if I'm supposed to find f of -4, I start with f of -4 equals. Then I substitute it in. 4 cubed plus, -4 cubed plus -4 squared minus 4 times -4 plus 41. Remember, first step is zero work. You just substitute it in because that really minimizes mistakes, and then also it shows your process that you actually substituted it in. All right, so then -4 cubed, so 4 times 4 is 16 times 4 is 64, and so is this positive or negative? Negative. So I got -64 plus -4 squared is 16. And then -4 times -4 is a positive 16, right? And then plus 41. So when I go to combine that, what's 16 and 16? 32. So 32 and a -64 gives me what? -32, and then plus 41, right? So f of -4 is equal to what? 9. Now look at A and B. We worked them completely differently. Anything in our final answer the same? The remainder. The remainder is the actual function value at -4. Make sense? If I substitute this in and I get a 0 remainder, that means it's a factor. Do we agree with that? Okay, so when that means and I get 0. So my function value is 0. It's on the x-axis. That's why it works. But if I do anything else, whatever the remainder is that function value. Now, which one could we work with a little bit more ease? Which one had prettier numbers, A or B? Okay. Hey, it's a matter of opinion. But let's say that I had to do like -13. Do you want to cube -13? No, but doing -13 over here might not be so bad, right? And so you can use that to evaluate. Now, we're going to go to number 2, but we're going to start with B, and we'll come back and we'll talk about these a little bit more. But we're going to start with B instead of A this time. And we're going to find f of 9, right? So f of 9 is equal to 7 times 9 to the 4th minus 63 times 9 cubed plus 9 times 9 minus 80. Now, my original intent was I was going to give you a couple minutes, let you work this out, and then we were going to talk about it. But because I know basically what you're going to do. but I don't want you to do what you would most likely do, which most of you, and not that it's wrong, I'm not saying that it's wrong, but we're trying to learn how to work smarter, not harder. Would I be incorrect in assuming that most of you would go ahead and figure out what 9 to the 4th is, like off to the side somehow, and multiply it by 7 and get that number? Is that what you would do? No? What would you do? Okay, well that's still 9 to the 4th. 81 times 81 would still give you 9 to the 4th, right? I mean, you still got to find those big numbers, right? No, that's it. Well, actually you can, because you could do 7 times 9 and then you would still have that 9 cubed to go with it. But you can't do 7 times 9 and then take it to the 4th power. Do you see the difference there? Like, so, no, I didn't. No, if you have this, so if you're going to do 7 times 9, this does equal 7 times 9 times 9 cubed. Isn't that the same thing? Right? Okay. But what you don't do, this does not equal 7 times 9 and then take that to the 4th power. That's a big no. You went the first one. Okay, that's fine. But you still have to do 9 cubed and multiply it, right? You're still going to get some big numbers. Would you agree with that? Is there still some room for error there? Okay, so let's think again. We're going to learn how to work smarter, not harder. These are the types of things that those PSAT and SAT questions kind of expect you to do. So we're going to work backwards as rewriting some of this stuff. So I'm going to just rewrite my minus 80. And then 9 times 9, that's pretty easy, right? What is that? 81. Okay. And that would be a positive 81. Now, I've got a lot of 9s going on here, right? So maybe I have to multiply them all out in the end, maybe I don't. But if I take this 9 cubed, that's 9 times 9 times 9, right? I'm just going to multiply 2 of them together and get 9 times 9, which is 81. And then I'm still going to multiply a 9 in there. And then I'm still going to multiply that 63. Okay? You with me on that? You see how I split that up? Okay, this would still give me the same thing, right? I would just need to multiply another 9 in there to get my 9 cubed. I just haven't done it yet, and I'm not going to. Then I'm going to move on to this. Okay, so just like Robert said, he wouldn't do 9 to the 4th necessarily. I mean, he would, but he would do 81 times 81, which is 9 squared times 9 squared. Does that make sense? It's the same thing. So if I just take 9 squared out of that, that's still 81. That still leaves me with 2 9s I have to multiply in. You agree with that? Here's one of them. And then I'm going to take the other one and multiply it by 7. What's 9 times 7? 63. Now, I want you to look at what we have right here. What happens with these two terms? They cancel out. Do you see how this is positive, this is negative? It's the exact same thing. So they cancel out. All I'm left with is 81 minus 80. And what's f of 9? 1. You will become a much stronger math student and a much less frustrated math student if you take a minute to look at what you have in front of you instead of just jumping in and doing math for the sake of doing math. Does that make sense to you? Because you're capable of finding 9 to the 4th power times 7. Like, you can do it. You're not going to enjoy it, and we might make some mistakes, but we can all do it. I might make mistakes too. But if you understand how the number, that's why I keep saying things like, if you understand how the numbers are built and how you can rearrange them, then that works too. I actually, the first time I did this, I did not do that the exact same way because I know what 9 cubed is. And so I just went ahead and did 9 cubed times 63. Or even if I didn't know what it was, it doesn't matter because here I can split this up and say that this is 7 times 9, right? 7 times 9 times 9 cubed. You agree with that? And do you see how that's 63 times 9 cubed? And that still would be positive and negative. They'd cancel out without me actually multiplying anything. You with me on that? That works too. I didn't have to multiply anything out. And the only thing we multiplied here at all was 9 times 9 and 7 times 9. That was it. Okay? But you got to be confident in what you're doing and understand kind of how things are built. That's not really what this lesson is about, but that was a good teachable moment for that. But we found f of 9, and it's 1. So now we're going to come over here. We're going to divide that same function by x minus 9, which means on the outside I get 9. On the inside, from here, I would get 7 minus 63, then what? Nope. 0. That was another big mistake on that test. Minus 80. So then my 7 comes down. This is positive 63. So this is 0, 0, 0, 0, 9, 81. So my answer here would be 7x cubed plus 9 plus 1 over x minus 9. Now, even though we didn't necessarily have to multiply out crazy numbers on B, which one of these was easier, A or B? A, for sure, right? Did you agree with that? And if what we're trying to do is evaluate the function, find f of 9, this right here, that's the same thing, right? Those are just two different ways to do it. This is how you have been evaluating everything, right? You substitute it in. That's how you learned your substitution. Nothing wrong with it. But you can substitute it in and find it that way, or you can use synthetic division. Okay? Does that make sense to you? So we can use it to evaluate, which you may choose to do in a lot of situations where you wouldn't want to just multiply this out, because this can get really ugly, especially if things don't cancel out nicely. We kind of got lucky there. All right, so what that brings us to is what's called the remainder theorem, hence the fact that we're using the remainder here, right? So the remainder theorem, if a polynomial function f of x is divided by x minus c, then the remainder is f of c. Oops. Yeah, sorry. F of c. Right. So when you use synthetic division to evaluate the function, that's actually called synthetic substitution. Because we're substituting the number in, just like I would, substitute 9 in for x or whatever, but we're doing it synthetically. So the main difference, synthetic division, the process is the same. The difference is when it's straight up synthetic division and you're given something like this, you're giving a linear factor, and so you basically have to solve that, like x minus 9 equals 0. That's where the positive 9 comes from. When you're evaluating, basically this is already solved, and this is the number that goes on the outside. Does that make sense to you? We're not changing the sign. That is the number. If it's not given to you in a binomial, then that is the number you're using. Don't be changing signs. You're going to be confused. So this says, use the remainder theorem, synthetic substitution, to evaluate f of x at c. So I could take -3 and substitute it in, right? But I'd have to take it to the 4th power. I'd have to cube it. There's negatives that I could mess up, whole 9 yards. Not impossible, but, it would take a minute, even if I'm good at it. But I can instead use synthetic substitution. So -3 goes on the outside. Then I have 1, 8, 12, -7, and -14. Okay. And then I'm going to bring down this 1. -3 times 1 is -3. 5, -15. I combine those, get -3. This will give me a positive 9. Combine those, I get a positive 2, -6. So then what's my remainder? -20. So when you answer this, okay, here's the other thing, is you have to know what you're doing and why so that your answers make sense. We are not going to write down x cubed plus 5x squared minus 3x plus 2 plus -20 over that. Nobody asked me for that, right? We are evaluating. So your answer is f of -3, that's where that comes from, equals this right here, -20. Easy enough? Do you think that's easier than actually substituting in that -3? Yes. Heck yeah, and a lot less room for error. I mean, still we can mess up because we're human, but a lot less room for error. Yes? You don't flip the signs that you did. You do not, because it is already solved for you. Because you're not flipping signs, you're solving it. So when it said divide by x minus 9, we had to do x minus 9 equals 0. So x equals 9, that's why 9 went on the outside. And that already basically has it for me. Okay? Anything else? All right. Flip it over on the back. We're not doing every single example because we don't need to. Let's see. Do number 6. Go ahead and work on number 6 on your own. I'll give you a second to work on that one. Oh, the first number 6. I'm sorry. I forgot there was 2 number 6s. I was like, where are you getting your numbers from? There's two number 6s, and I don't know why. You don't have to erase that. We're not going to do this one, so if you wrote it up, just ignore it, but go back to the first number 6. I'm very sorry about that. I was wondering how some of y'all come up with the numbers you had. Make sure you have that 0 placeholder, because if you don't, that's going to cause you problems. Do you agree with what I have up here? Yes? So my answer then is what? F of negative 2 equals negative 5. Good. That is my answer. It's not just negative 5. It's not anything with any x's in it. That is my answer. Everybody good? Any questions? All right, so you're erasing. Just tell us what you did wrong. It's okay. I mess up all the time. Oh, you don't have to erase it. It's fine. Oh, it's bothering you. Okay, it's fine. If it's bothering you, it's fine. Everybody good? No questions? All right, let's do number 8 together just for the sake of it. So another number, number 4 goes on the outside because we're evaluating CF equals 4. This is going to give me a negative 2, 7, then what? 2, then 0, then negative 1, then 8. Okay, good. It's 4 times negative 33. Y'all agree with that? Yes or no? Yes. Because 4 times 30 is 120. 4 times 3 is 12, so it's negative 132. Good. Very good. And then negative 132 and 8 gives me what? Negative 124, because I could subtract 10 and then add 2 back if I wanted to. So negative 124. Okay, good. So then my answer is f of 4 equals negative 124. Okay, everybody good? Any questions? All right. Let's look at, we're going to do both of these application problems. So it says the number of tickets sold during the Oakdale High School football season can be modeled by this equation, where x is the number of games played. Use the remainder theorem to find the number of tickets sold during the 7th game of the season. All right, so they give me the equation, right? And it tells me to use the remainder theorem, so I'm going to use synthetic substitution here. So I'm going to have 1, and then negative 14, and then 45, and then 68, right? What goes on the outside over here? 7, because it's 7th game, so x equals 7, right? So 7 goes out here. This is 1, 7, negative 7. 7 times a negative 7 is negative 49. This is negative 4. It's negative 4 times 7. Negative 28. So my remainder is 40. Okay, and I heard Tony say, oh, it's easier than I thought it was. Yes, just because it's an application problem doesn't mean it's hard. But if I had to substitute in 7, like this is a question that you could have had years ago because all it is just a plug and chug problem. But you can substitute in 7, but then you're going to have to cube it, and then you're going to have to square it, multiply by 14. Like the numbers get yucky, right? Were these numbers yucky? No. Okay, now I do not answer this one by saying f of 7 equals 40 because nobody asked me for f of 7, right? I need to actually answer the question. The answer also isn't just 40 tickets, right? Because what about 40 tickets? It says the number of tickets sold during the 7th game. So I could say 40 tickets. Good. 40 tickets were sold during the 7th game. Now, let's talk about reasonableness of an answer, because that's where some of us are just living in another world. Sometimes you get an answer and you're like, woohoo, and you're so proud of it. But if you think about what it says, like, does it make any sense at all? So 40 tickets being sold to a high school basketball. Or is basketball? What did it say? Football. Thank you. I'm sorry. I was like totally went blank. Can't even see the word. Football. So 40 tickets being sold to a football game? Okay. Set. Maybe it's set. Maybe it's a really small school. I mean, if it's a really tiny school, that might be legit, right? Or it might be a really bad team. I don't know. But, so I would say, kind of does seem a little weird, but it's not way out there. If it was like 40,000, I might be concerned. But then if you actually read what we just wrote, 40 tickets were sold during the 7th game. So it's actually during the game. That doesn't include season ticket holders or any pregame sales. It's all the people that were late. So then does that make that a little bit more of a legit answer? Okay, so make sure you're reading about what it actually says and what it means, okay? Now we're going to do number 10 because it's got the decimals in it, which I know give you some anxiety, but it's all good. That's why we're working it together. All right, so the distance in feet that a person travels on a snowboard is modeled by this equation, where t is the time in seconds. Use the remainder theorem to find the distance traveled after 1 minute. Okay, so my equation, 0.6, and then 10, is that it? 0, okay, because I have to have that for that constant term. Then I got to figure out what goes on the outside there. Is it 1 or is it 60? 60, because it says t in the time in seconds, and we have 1 minute, so t is 60, okay? A little late to the party, but that's all right, we're good. All right, so it's 60. Be careful with that because, yeah. All right, so I bring down the 0.6, and then we don't have a panic attack just because it's a decimal, right? Multiplying decimals by decimals is very easy. We can think about it in lots of different ways, even as a fraction, sometimes that's easier. But when you actually multiply, when you first learned how to multiply decimals, you just multiply what you have, and then you move the decimal place over, right? So what is 6 times 60? 360, right? 360. And then how many times do I move the decimal place over? 1. So my answer is 36. Does that make sense? That's it. See, that wasn't that bad. And then this right here gives me 46. Okay, so now I've got to multiply 60 times 46. Again, no big deal. 60 times 40, what's 60 times 40? 2,400. So 60 and 40, that's 24, and then I've got to put on the 2 zeros, right? And then 60 times 6 is what? 360. And then together, that's where I get that 2760. Okay, and then I have to add that to 0, so that's not real hard, right? It's 2760. All right? Just learn how to simplify things for yourself. And I would suggest, especially numbers like this, myself too, I would, write them down off to the side so I didn't lose what the number was in my brain. Okay, so then I've got to answer the question. So it says, find the distance traveled after 1 minute. So a person on a snowboard, bless you, will have traveled, oh, that's a B, traveled 2760 what? Feet after 1 minute. Okay. That make sense? So make sure you're actually answering the question. Learn how to, I know that y'all know how to do stuff like this from English. You just use the words in there to make your sentence. But you got to make sure you're clear about your answer. Okay? Any questions? And that's 2 words. A person is not 1 word. I have bad handwriting and it just all crushed together. Okay? A person. Yeah, it's a new word. All right. Any questions? We good? All right. This is not that bad, right? There's not even that many questions on the homework. All right. Go ahead and glue this in right now so you're not scrambling at the last minute.